Welcome to Clean Talk. I'm your host, Brad Whitchurch. It is November 10th, and we're coming to you live from beautiful sunny downtown Orlando, Florida. We're here in the Seal Shield Studios, and live with me in studio is my very special guest, Skipper Bond. Skipper is the CEO of Henley Ion, and we're excited to hear about some new emerging technology in the infection control space. One of my favorite topics, and I'm super excited to have you here, Skipper. Thanks for coming to the show.
Thank you so much. It's a pleasure to be here.
Well, we're really glad to have you. Skipper flew in from New Orleans just to be here live with us in studio today. Skipper, what more can you tell us about Henley Ion and your background and why you're here today?
Sure. Well, born and raised in New Orleans, and find myself in this position these days as CEO of an emerging biotech company. Began my career in marketing and public relations. Spent about 20 years building an agency, working with all sorts of, national brands, local brands, not only in New Orleans, but across, the globe, really. And, the agency certainly took a little hit because of COVID, because we work in retail and hospitality and entertainment. And I think those three sectors really, took it on the chin. But I found myself over those years becoming really close with a woman named Connie Parker, who is the chair of Henley Ion, which is our new company. And about 18 months ago, when we really realized what was going on with COVID and that it was transmissible in the air, we started to think about how we might help. And, that's how Henley Ion was born. And so for the last 18 months or so, I've been the CEO, developing some pretty amazing technology. And here we are today.
Well, you've been busy over the last 18 months, and you do have some exciting technology that we're looking forward to talking about here today. So the connection that we have is Dr. Chad Roy, who's on the Seal Shield Healthcare Advisory Council and was one of our guests here on Clean Talk. I believe episode 7, really a great episode to go check out. But he is your science consultant for Henley Ion. How'd you get involved with Chad?
Yeah, so Chad is phenomenal. So Chad runs the BSL-3 high containment lab at the Tulane National Primate Research Center. And when we realized that we wanted to base this company in New Orleans and build it there, we wanted to find a partner to assist with our research. And I essentially just got on the horn and reached out to the Primate Center and was introduced to Chad that way. And after many, many, many months of courting him and really just, putting forth this technology as a real solution to the pandemic, they decided to bring it into the laboratory and do a bunch of testing with us. Chad, he kind of jokes that, throughout this pandemic, so many new technologies has hit his doorstep, for evaluations. And he sent everything out except for this. He wanted to keep this in his lab because, he truly thinks, like we all do, that this is, a game changer in, protecting individuals from airborne biopathogens.
Well, there are a number of technologies that you're working with, and Dr. Roy is the aerobiology expert, and that's how Seal Shield became aware of your technology, because he's on our Healthcare Advisory Council. And like you said, he sees a lot of stuff that he doesn't like very much. Sure. So when he called us and said that we really had to take a look at what you guys were doing, he's pretty excited about the technology. And when Chad was on our show, he talked a little bit about the science of this new emerging mask technology, because that's what we're talking about. And we're going to talk about the mask technology specifically, and then maybe some other things that you guys are doing around that same technology for protecting the air from pathogens. But I'd like to take a step back and let's talk about kind of the genesis of how all of this came about in the first place. Why focus on masks? Why focus on the air? What was the motivation?
Sure. So my partner, Dr. Julian Henley, the namesake of the company, about 11 or 12 years ago, when anthrax was a big scare, when folks were being mailed anthrax, he was approached to invent something to help clear rooms of airborne weaponized anthrax. So he did. And after, going through that process, really developing some cool technology, that whole scare went away. And so Julian had to shelve the technology. And, fast forward to now, about 18 months ago, he realized that the COVID was in fact transmissible via the air. And as an MD, he felt morally obligated to take it off the shelf and develop it. Because he can save more lives, we can save more lives by bringing this tech to the market than Julian can in the operating room. And he's just, he's a prolific inventor. He emigrated to the US when he was about 12 years old. He couldn't speak any English. He grew up behind the Iron Curtain in Eastern Europe, with Russian tanks in his backyard. So his family decided to come over to the States. He landed in Spanish Harlem, couldn't speak any English. Ended up getting a full ride to Harvard when he was 16. He graduated, top of his class in applied mathematics and physics. And so when you graduate top of your class in applied math and physics, you go work with defense contractors and government. So the first part of Julian's career, he spent it, developing weapons systems. And after a while of doing that, he decided that he didn't want to use his genius, and he truly is a genius. With coming up with more creative ways to kill people. So he ended up going to medical school at Albert Einstein up in New York, then landed at Yale School of Medicine for over 20 years. He was on their clinical faculty, but all the while built a surgical practice in Manhattan. And when he identified a problem performing surgery, he would invent, a way to solve it. And so, over that time, he's amassed 34 patents. And, so he loves to apply that physics and math background, to being a doctor. So he has quite a perspective. And so, so that's kind of, how it all happened. And
Well, you said he's a genius,
Yes.
first in his class at Harvard. He must be, what they call the guy who's last in his class in med school?
A doctor.
Doctor.
Exactly.
That's right. That's right. Well, I'm excited to talk about this mask technology.
Yeah.
Chad, we got into some of the details without
Sure.
on a more general level.
Sure.
And I know he's the science guy, but what more can you tell us
Sure.
about the technology that's going into these masks and why it's superior or potentially game changing?
Yeah, so what we have essentially done is micronize electrostatic precipitation. And that's something that's never been done before. Electrostatic precipitation has been around since the Industrial Revolution began, and it's used to keep pollutants out of the environment. And, whenever you see a big manufacturing facility or plant, those big smokestacks are gigantic electrostatic precipitators. So what we've done is micronize it and adapt it to the human being in order to protect the airway from biopathogens. And it's pretty remarkable. So our mask technology has a little cylinder, and through the middle of it is a rod that's emitting electrons. And then the inner wall of the cylinder is a collector plate. So what happens when you breathe in and you have, your breath containing, virus or pathogens, those pathogens attach to the electrons that are coming off of this emitter rod. And then those electrons are attracted to the positively charging collector plate. And then what you breathe in is clean air. And it's all done without really any impediment to breathing. So very, very low pressure drop, if any at all. And what we found in our initial rounds of research with Chad is that we removed virtually all virus from the airway, and that's with virus being pumped in at 4 times normal breathing, and also at a concentration of hundreds of millions of times, viral concentration, and that's a viral concentration you would never find in the natural world. So, so the tech performed, just remarkably well. It exceeded all of our expectations. Under the most rigorous testing conditions. And so that's when, we were like, oh my gosh, I think we have something here. And so we've since, taken that initial prototype that was running in the labs at Tulane, and we've done some iteration. We've made it more streamlined, more aesthetically pleasing, lighter, and have even enhanced the performance some as well. So this piece of tech essentially is a micronized electrostatic precipitator that has just widespread application.
Well, I think the benefit is, and it's something that we can all relate to because we've all been living in a mask world, right?
Sure.
And you mentioned that this technology doesn't rely on pressure, right? So all the other masks on the market rely on pressure and filtration, right? So you breathe in through a filter, particles are captured and prevented from entering into your lungs. If you're wearing an N95 mask, they can be potentially up to 95% effective, but it can be very taxing on your respiratory system. And we all know that it's not comfortable wearing the masks. And especially if you're a professional that has to wear these masks for extended periods of time, it can be very taxing on the respiratory system. And I've been talking about this for a while, and I don't have a lot of evidence to back it up. But, when you leave the N95 mask world and you start dealing with these cloth masks, consumer grade masks, we don't know what's being off-gassed from those materials. There are not the studies available long-term, what the impact is on society from wearing, all these unregulated cloth masks on a regular basis. We still don't know what the results of that will be. This really eliminates a lot of those challenges or discomfort of the current mask technology because there's no negative effect to the respiratory flow, right? There's no filtration, correct?
No filtration whatsoever. So it's a very, clean, flow of air with no impediment. And, we're not a cloth mask. We're not a surgical, paper mask. Those masks need to be, fitted really tightly around, your face in order to really truly be protected because, air flows across the path of least resistance. So, airflow does get in those gaps. And because of our, pretty low, if not zero, pressure drop, that's not an issue with our technology.
And I'm guessing you can actually hear people talking when you're not blocking their voices and their air pathways with a filter, right? That's another huge advantage.
Yeah, you can definitely hear. And, we've left room with this particular device for some bells and whistles, potentially a speaker and a microphone, and it's clear. So you can, read, just verbal communication,
facial expressions.
Yeah. Pretty exciting.
Yeah, fantastic. So we had some questions when we were talking about this technology initially. People wanted to know, how big is it?
Yeah.
So tell us a little bit about the specifics.
Yeah, so it sits right here. There's a little cartridge that goes right here. The total weight is about 6.5 ounces, so it's not terribly heavy. There is a power source that has a 12-hour battery. And, that can affix just to the back of the strap right here or, back here on your belt, and you just have a little cord. The original design had everything up in the face, and it was just way too cumbersome and too heavy. And you couldn't wear it for that long. So we decided to separate the electronics and some of the microprocessor to the power bank. But it's pretty lightweight. It's a very, very high grade, soft medical silicone, around the face. So it seals, very well, and it's very comfortable. It's we're nearly there. We've always find ways to refine and improve. And I think the saying is it's perfect is the enemy of great. Something like that.
Right.
So we're pretty close, and we're very happy with where we've come.
Well, that's going to be your job as the CEO to reel in those engineers because they always can make it better, but we got to bring something to market.
Exactly.
When can I get this mask? When is it coming to market?
Well, we're hoping, maybe third or fourth quarter of next year. There are, still some things that we need to do. We are gearing up to talk with some of the regulators about the technology. We're talking with some other folks about, working with us on that. But we feel very confident. We just know that we have something that can save lives. And, that's why we started to do this in the first place. It's a brand new technology that's being used for this particular purpose. So some people are not really sure what to make of it. And we kind of joke around that the greatest thing that we have is this new technology, but also the worst thing is that we have this new technology. And So we're close.
Yeah, well, yeah, you have to change habits. You have to make the market, but you've built a better mousetrap.
We have.
And I, for one, am looking forward to wearing my first Henley Ion mask sometime next year.
I like to hear that.
Yeah. So what else can you do with this technology, or have you been working on other things in infection prevention as well?
Sure. So we are in the midst of developing an HVAC product that utilizes the same technology, the electrostatic precipitation, but on that, we're actually taking it a step further and incorporating the generation of ozone, but keeping the ozone within very safe levels. And so it's kind of a 1-2 punch. And
Well, let's talk about that for just a second, because we all have heard that ozone is bad. It's bad for the environment. There's regulations on how much ozone is safe, for instance, in a healthcare environment. And as you know, Seal Shield is involved in UVC disinfection. Some of the UVC source emitters produce ozone. You want to be careful that it's within the safe limits. What's the pros and cons of ozone? Why is ozone good?
Well, it's got a lot of really positive qualities when you're talking about breaking down virus or pathogens. It renders, virus inactive, so it's unable to replicate. And as long as you keep it within a safe level, it's not going to harm you. Julian likes to call that the therapeutic sweet spot, and that's with any medicine. Too little won't do anything, and too much, would be harmful. So, our technology modulates ozone, and there are a lot of ozone generators out there, and a lot of ozone generators are put on homes and utilized in many ways, but it's kind of a one or nothing deal. There is no modulation, and our technology, it's a patented system that we've built, allows one to keep the levels within the HVAC system itself, like the ducts, the air handling unit, at a particular level, while we're keeping the levels in the living space or occupied space, well below the OSHA levels. And, the technology solves a lot of problems. The CDC has all sorts of recommendations with what to do with HVAC these days, upgrading to a higher rated MERV filter, but the majority of systems that are on the market aren't equipped to push air through those filters. They also recommend turning the air over more for dilution, so letting in more outside air. But that's just, the end user loses a lot of tonnage. It's just not energy efficient. So what our system does is eliminate the need to do that. And it just got a lot of benefit in terms of, transmission of virus, that mitigating that, mold remediation, odor removal. There are a lot of applications for it. So
there absolutely are. And I've had a little experience in the air purification space. We found at Seal Shield that there were a lot of obstacles in introducing novel air purification systems into healthcare. I can tell you that we went into a major healthcare system on the West Coast. And of course, healthcare is standardized on HEPA filtration and positive pressure. But as you know, HEPA filters are only catching particles up to 0.3 microns, and all the pathogens we're concerned about are much smaller than that. So they're blowing right through these HEPA filters, but that's compliance. So we went and did Anderson air sampling testing in a major healthcare facility. We found every kind of gram negative, gram positive, every kind of pathogen you'd be concerned about in the OR theater and in sterile processing. So the instruments are coming out of sterile processing. They're coming out of an autoclave. They're absolutely sterile. They're being laid out to dry in air that is filthy. And we had a PCO technology, photocatalytic oxidation, that is also an air purification technology that's been emerging as a result of the anthrax scare as well. Wow. And it was highly effective. But what we found was that the healthcare systems didn't want to implement it because they're already compliant with their HEPA filtration systems. That's old thinking, right? And in fact, I mentioned to you today, there was an article in US News and World Reports this morning that because of the pandemic, we're being forced to look at antiquated infection prevention measures. And they talked about air purification, and they talked about masks. And I think we're going to see the proliferation of more N95 masks. There was a shortage in healthcare when the pandemic happened, and hopefully we'll be seeing the Henley Ion mask really taking over that market space because it's a better solution. But I'm excited about the HVAC system. We know it's a problem in healthcare and other environments, and to have a truly novel approach that could be a disruptive technology is super exciting. And that's why I'm glad you're here with me today, Skipper. And we love healthcare innovation. If anybody in our community has any questions for Skipper, we've got the chat open, we've got our questions open. Feel free to send in your questions and we'll take them live on the air right now. A lot of challenges in being the first, as you mentioned, that you're creating something new, as a startup company, as a technology innovation company. What are some of the challenges that you've been facing over these past 18 months while you develop these technologies for our benefit?
Sure. I think, we learn so much every step of the way. And, I think it's critical to have the right people on your team, the right talent. And, we have an amazing team in terms of industrial design and engineering and on the science side. So I think, that's a challenge that must be overcome. I think, what we're doing is probably the hardest thing to do. And that's, we've identified a problem that needed to be solved. And, we came up with a way to solve that problem. And, taking that concept to a working prototype, to evaluations, and then go to market, it's, that in itself is a challenge. I think because it's a new technology, there's an education component, and we have to really explain to folks what it is that we're doing and how this is going to be of value and benefit to them. I think we've done a pretty good job so far laying that out, to the end user as an individual, and then to an institution on the HVAC side. So yes, but we're meeting the challenges every step of the way. And I'm sure there are going to be many more coming down the pike, but
it will be a roller coaster ride, but you have a clear vision of the end goal. And that's what's most important for an innovation company. You mentioned regulation before. What kind of regulatory hurdles do you anticipate? And what is the path of least resistance?
Well, because we're not a filter, that falls in the realm of NIOSH. So they're determining, well, we've had a couple conversations with them a while ago. We're going to start re-engaging with them again. So we're really trying to figure out the right path, whether it is NIOSH, whether it is FDA, or could we be integrated into an existing respirator or something that's already been certified. We see the technology as a standalone technology that is the primary source of protection, but we also see the technology as a secondary mechanism for something that's already out there. So we're working through that. We have a great organization with whom we're working, Intertech, that's been advising us every step of the way, and we're getting close to mapping that out a little bit further.
And is it safe to say that you're looking for partners that can help you commercialize this product or potentially invest in some of the emerging technologies you're working on? What are you looking for in the marketplace that maybe some of our folks here on the Clean Talk podcast audience might have some interest in?
Yeah, I think, we're looking for partners to help in terms of commercialization, and I'll leave it at that. We're an R&D company. I think at the core, we have a brilliant scientist and a great team to develop technology and to bring it to a certain point. And we're looking for folks to help us, maybe commercialize further and help us get to market.
Sure.
Yeah.
Well, certainly Seal Shield is very interested in the technology. Anytime Dr. Roy comes and endorses something, we definitely have to take a look at that. So I'm really glad that you've come in here today to speak with us and to share this exciting news with our community and with our audience. If you have an exciting technology that you'd like to share that can help support our mission for infection prevention, reach out to us here at Clean Talk at cleantalk.tv, or you can call us here at Seal Shield toll free 87 Seal Shield. That's 877-325-7443. We'd love to hear from you, possibly get you on the show, and maybe we can collaborate with the community to help you with your technology or solution. We're here live with Skipper Bond, the CEO of Henley Ion, talking about some incredible new technology that they have developed that can be commercialized in the mask space and in the HVAC space. Is there anything else coming down the pipe, or anything that any other thoughts on things that you guys see in the future, that maybe future projects?
Sure. The technology can be adapted a number of ways. We're looking at elevators. We're looking at, transportation, whether that's a bus or rail. Refrigeration is another opportunity, we think, and even aviation. Those planes need some help with sterilization as well. So,
we sure do.
Yeah, we've got a lot of opportunity, but we're trying to stay very focused right now. We want to get our personal protective device, is what we're calling it. It's not really a mask. I mean, it's a device. It's a cutting edge piece of tech, and we want to get that to the market as quickly as possible so we can save lives. I mean, that is the reason we started this company, is to save lives.
Well, the market wants you to get it out there as quickly as possible too, and so we look forward to seeing that next year. Now, I know you're a New Orleans guy,
Yes.
and certainly tell us about how things are going in New Orleans. Is New Orleans back?
New Orleans is coming back. We made it back. Then we had a minor setback with Hurricane Ida, which disrupted some infrastructure on the electrical side, but we're back. Tourists are coming back to the city. I was downtown at the Saints game this past weekend, and it was just so amazing to see all of the people. Our offices are in the Garden District, so every day I just step outside on Magazine Street, and I'm seeing more and more people walking up and down the streets.
Well, that's great.
Jazz Fest is back.
I was going to say, I see your pin there.
Yes.
Well, what can you tell us about Jazz Fest? Now, you're on the board for Jazz Fest, is that right?
Yes, I'm on the board of directors of Jazz Fest. I'm on the board of the New Orleans Jazz and Heritage Foundation, which owns the Jazz Fest. And we had 2 festivals cancel, unfortunately, but we are on schedule to be back in the spring. So Friday, April 29th through Sunday, May the 8th. So it's 7 days total. It's the first, it's Friday, Saturday, Sunday, then the following Thursday, Friday, Saturday, Sunday.
Well, now it's been a couple of decades since I was at my last Jazz Fest.
You're coming.
Okay, well, I can't wait. But for those that don't know, it isn't all about jazz, right?
Yeah.
There's a lot of headliners and a lot of different musical styles.
Yeah.
Can you give us some names? Who can we expect at Jazz Fest?
I would be booted off the board.
Oh, that's confidential.
Yeah, so we should be announcing, around the first week or so of January. And it's every genre of music. It's large stadium, acts, and down to, very local, indigenous, acts. And so we've got, many stages that showcase every single genre of music. Our, mission there is to promote Louisiana culture. But when we have, some of the big acts like the Foo Fighters, that helps bring the people.
The Foo Fighters, is that a leak?
No.
Oh, okay.
No,
all right.
but,
I thought we
just an example of the type of act. We've had some big ones, Bruce Springsteen, the Doobie Brothers, Katy Perry, actually. You name it, Dead & Co. Lots of great acts.
Well, fantastic. We'll look forward to that. And I'm going to take you up on that invitation.
You got it.
So you've been very forthcoming about the Henley Ion technology, but quite tight-lipped about what we can expect from Jazz Fest. So we'll have to stay tuned for that.
Right.
When are they going to start announcing the acts?
That'll be around January.
Okay, fantastic. Well, looking forward to that.
Awesome.
Our guest today has been Skipper Bond, CEO of Henley Ion, talking about some disruptive technology and infection control in the mask technology and in HVAC technology. If you're interested in finding out more, you can contact us here at Clean Talk by going to our site at cleantalk.tv, register to be a member of our community, and watch our previous episodes. And if you'd like to find out more about Henley Ion, you can call us here at Seal Shield at 87 Seal Shield. That's 877 325-7443. And join us every week at 3 p.m. Eastern Time on Wednesday for a live episode of Clean Talk each and every week. Until then, for my guest, Skipper Bond, I'm your host, Brad Whitchurch, reminding you to keep it clean.